Okay, this is problem 3 from chapter 27. We're working with linear regression and trying to deploy hypotheses testing as a tool to give us confidence when we believe we have a linear association. So this particular problem is sort of a follow-on from the first problem where we were looking at the percent of people that are willing to vote yes for a qualified female candidate for president. So in that survey, there's also a measurement of the people that have no opinion. And we're kind of interested to see if that group is changing. Obviously, well, I don't know if it's obvious, but people that are trying to get votes, a lot of times when people's minds are made up, it's hard to change people's minds. So what you want to do is you want to look at the population who hasn't made up their mind and see if you can change them. So that's why this particular kind of question might be important. So the first thing they do is they say, well, let's state a hypothesis. So we would want to say something that about there's no change. And then we would want to look to see if there's proof of a change. Okay, so here we would say something like there has been no change in the percent of people willing to vote for a qualified female candidate for president. And so if we had a line between, if we had sort of like the percent no opinion, and then we had date, like year, like time, okay, then we're sort of saying that line, if we collected those days after different years, that line would be, the slope would be 0. Okay, so we would say something like beta 1 equals 0. All right, so then the alternative would be something similar. There has been a change. And then we would say the rest of the stuff, rest of the content, but then we would say beta 1 is not 0. So the slope of that line is not 0. It's either positive or it's negative. Something like that. Okay? So those are our hypotheses. Now they want us to perform a test. So let's think about this. Again, I like to start with a picture. Basically what we're saying is, okay, the null hypothesis is there's been no change. So if we thought of this as a target, it would be 0. Okay, and then we know there's going to be some variation, but it wouldn't vary too far away from 0. Okay, so by the way, the degrees of freedom, I didn't mention this in the last video. For this particular, this is a student T model, because it's a quantitative, the slope is a quantitative variable, and the degrees of freedom comes from the computer printout. It's 14. Okay, so this is our model. The question is, what's our standard? What's the size of our standard deviation? Okay, so and our test statistic B. Well, actually, let's just talk about that. So the model that we ended up producing is right here. So percent no opinion, put a hat on it, is equal to 7.693 minus 0.043 times year. So this is our model, so we can predict, and then our test statistic is the slope of our model, 0.043. So it looks like it's pretty close to 0. Oh, it's negative, by the way. Negative. Okay, it's pretty close to 0, but we need the standard error to know how far. We can't measure how far that is away from 0 without the standard error. So we would say t equals minus 0.043, and we're going to subtract the hypothesized value, which is 0, and then we're going to divide by the standard error of b. Okay, this is b minus beta 1. Okay, so we get that right from the computer printout. Here it is. The standard error of the slope is right there. So we get minus 0.043 minus 0 divided by 0.0353, and that comes out to be negative 1.21. So we get the t, they call it the t ratio on the computer printout. We get the t value. So now we know it's 1.2, negative 1.2, so it's right about here. Alright, so their p-value would be the shaded area, 2 times this. Okay, so that's the value. Okay, so p-value equals the or 2 times y2, because we made it 2 times the probability of t less than minus 1.21, because that's we made it 2-tailed when we said not equal to. Okay, so if we were working with data and we didn't have the computer printout, I just want to make sure you know this, this would be t, c, d, f, and we'd want to go from negative infinity, because this tail just keeps going, from negative infinity to our t value, so negative 9,999 to minus 1.21, and we would give it our degrees of freedom of 14. Okay, but since we have the computer printout, we see that our p-value is 0.2458. So 0.2458, which is approximately 24.6%. Okay, so we're pretty trained now. The p-value is large. So we fail to reject HO. Alright? What we would say is there is no evidence that the percent of people with no opinion on voting for a qualified female candidate for president has changed. Okay, there's no evidence, so we just can't say anything. Okay, now the last question, C, on the next page that we see the scatter plot and for no opinion. How does the scatter plot change your opinion of the trend? In no opinion responses, do you think the true slope is negative? Does this change your conclusion? Explain. Okay, well, I think what they're getting at here, what they want you to see is that the center of the x values is right here. so to speak, or the center of year values, somewhere in here. So this clearly looks like an outlier. So the question is, does it have leverage? Does it influence? So since it's so far away from the average or typical value of the predictor variable, it does. And so it's probably pulling this line up. So that's one of the reasons why the line actually has a bit of a slope. And also there's another point over here that is a long ways away from the typical value, and maybe not that far away, but far enough so that it's kind of pulling the line this way. So between these two, or given these 2 points are in the data, that probably explains why we have a slope. Otherwise, the slope is probably 0 or very close to 0. So by doing the hypotheses test, we'll be able to say that, okay, even though there is some bit of a slope, it's not significant, statistically significant. It doesn't rule out that either there's chance or there's something else explaining this other than a true relationship between these 2 parameters. Okay, so that's sort of the answer to that question. So in my opinion, I would want to investigate a little further the cause of these values. These are way off. Something's not right. Okay, so that's how you do this. Again, we're doing hypotheses test of slopes, and we're using the computer printout to do the bulk of the work for us. What we're doing is thinking.